Consider the series which starts from 1 and goes to infinity with the sequence 1 over n plus 1 minus 1 over n plus 2. So will the series converge or will it diverge? So we need to determine if this series has a finite sum. If it has a finite sum, that means that it's going to converge. If it goes to infinity or negative infinity or it doesn't exist, then it's going to diverge. So how can we determine the sum of this particular infinite series? So what we have right now is a sub n, the sequence, which gives us a list of terms in the sequence. And what we need to do is find a general formula for s sub n, the partial sum of the sequence. And if we take the limit as n approaches infinity for the partial sum formula, that will give us s. And so we need to determine, is this infinity or is it a finite number? And this is equal to the sum of the series. So how can we do that? Well, let's begin by listing out the terms of the sequence. So the first term, a sub 1, if we plug in 1 into this expression, n plus 1 is 2, n plus 1 plus 2 is 3. So this entire thing is the first term. Now the second term, a sub 2, if we plug in 2 into n plus 1, that's going to be 3. And then if we plug in 2 here, 2 plus 2 is 4. So this is a sub 2, the second term. Now let's find the third term. So 3 plus 1 is 4. And 3 plus 2 is 5. So this becomes 1 over 5. And so this is a sub 3. And then this will keep on going. Now let's get the a sub n minus 2 term. So replacing n with n minus 2, we have n minus 2 plus 1. So that's going to be n minus 1 on the bottom. Then n minus 2 plus 2, that's simply n. Now let's get the a sub n minus 1 term. So n minus 1 plus 1, that's just n. And then n minus 1 plus 2, negative 1 plus 2 is 1. So it becomes n plus 1. And finally, the last term of the sequence is a sub n. And a sub n is what you see here. So that's just going to be 1 over n plus 1 minus 1 over n plus 2. So now notice that these two will cancel, and then these two will cancel. Let me use a different color. Negative 1 over 5 will cancel with something in the series. And then 1 over n minus 1 will cancel with something else. And then negative 1 over n plus 1 over n, they cancel. And these two cancel. The only two things that will not cancel is the first term and the last one in the sequence. So now this gives us a general formula for s sub n. So s sub n is going to be 1/2 minus 1 over n plus 2. Now whenever you get a series where the middle terms cancel, and it basically turns out that s sub n is just the first and the last term, this is a telescoping series. Now, once you have the general formula for s sub n, take the limit as n approaches infinity for the partial sum formula. And so we have the limit as n approaches infinity of 1/2 minus 1 over n plus 2. So this is equal to 1/2 minus the limit as n approaches infinity for 1 over n plus 2. Now, for 1 over n, as n approaches infinity, that's going to go to 0. So 1 over n plus 2 will also go to 0. So this is going to be 1/2 minus 0 which is 1/2. So this is the sum of the series as n goes to infinity. So because the sum is equal to a finite value, we could then say the series converges. It converges to 1/2. Now let's try another problem. So let's say the sequence is 1 over n times n plus 1. So go ahead and determine if the entire series is convergent or divergent. So you know the title of this video is telescoping series. So therefore you know that this is some type of telescoping problem. But if you start plugging numbers in, this is what you're going to get. If we plug in 1, it's going to be 1 on the bottom times 1 plus 1, which is 2. So that's going to be 1/2. If we plug in 2, it's going to be, this is 2 times 3, which is going to be 6. And then if we plug in 3, 3 times 4 is 12, and so forth. So this doesn't look like a telescoping series. And the reason for that is we need to change the form of the problem. What we need to do is take this fraction and decompose it into two simpler fractions. So we need to use partial fraction decomposition. So let's take a minute and focus on that part. So we're going to set this fraction equal to a divided by n plus b over n plus 1. Now, if you're new to this process, I have another video entitled Partial Fraction Decomposition, and I recommend that you watch that video before doing these problems. But let's get back to this problem. So what we need to do is determine the values of a and b. So what I'm going to do is multiply both sides of the equation by n times n plus 1. So when I multiply this fraction by that expression, these two will cancel. And so I'm just going to get a 1 on the left side. Now, if I take a over n and multiply by this, n will cancel, giving me a times n plus 1. And then if I take this fraction, multiply by n times n plus 1, the n plus 1 factor will cancel, leaving behind b times n. Now, what I'm going to do is, first let me get rid of this. I could use the extra space. So I'm going to plug in 0 into this expression so that this will disappear. So when n is 0, I'm going to have 1 is equal to a times 0 plus 1. So that's 1 is equal to a times 1. So basically a is equal to 1. Now, when n is negative 1, this will disappear because negative 1 plus 1 is 0. 0 times a is 0. So I'm going to have 1 is equal to b times n, and n is negative 1. So 1 is equal to negative b, which means b is negative 1. So therefore, I can rewrite the series like this. This is going to be a over n, which is a is 1, so 1 over n. And then it was plus b over n plus 1, so b is negative 1, and then over n plus 1. So now this looks like a telescope in series. So let's begin by listing out the terms. So when n is 1, the first term is going to be 1 over 1 minus 1 over 2. And so that's a sub 1. Now let's find a second term, a sub 2. So it's going to be 1 over 2 minus 1 over 3. And then let's move on to the third term. So plug in 3 into this expression. This is going to be 1 over 3. And 3 plus 1 is 4. So that's going to be minus 1 over 4. Now let's get the a sub n minus 1 term. So replacing n with n minus 1, we're going to have this. And then n minus 1 plus 1, that's just going to be n. And then finally, the last term, a sub n, is exactly what we see here. So it's 1 over n minus 1 over n plus 1. So all of this is equal to s sub n. Now let's simplify the expression. So we could cancel negative 1/2 and 1/2. We could cancel negative 1/3 plus 1/3, and then negative 1/4 plus 1/4, which is somewhere in the middle of the sequence. And then we can also cancel something here with 1 over n minus 1. And then negative 1 over n plus 1 over n cancels as well. So s sub n is going to equal to the first term minus the last term. So we could say that s sub n is 1 minus 1 over n plus 1. So now let's take the limit as n approaches infinity for the sequence of partial sums. So that's the limit as n approaches infinity, 1 minus 1 over n plus 1. And so that's equal to 1 minus the limit. And then just like 1 over n goes to 0, 1 over n plus 1 will also go to 0. So this is going to be 1 minus 0, which is 1. And so the sum of the infinite series is 1, which means that the series converges. Now let's work on one final example problem. So let's say if we have the series with the sequence 2 divided by n squared plus 4n plus 3. So go ahead and take a minute and try this problem. Feel free to pause the video. So what do you think is the first thing that we need to do in this problem? The first thing I would recommend doing is simplifying the expression. Somehow, we need to put it into a form where it can be written out as a telescope in series. So the first thing I'm inclined to do is factor out the trinomial on the bottom. So what are two numbers that multiply to 3 but add to 4? This is going to be 1 and 3. 1 plus 3 is 4, 1 times 3 is 3. So we could factor it like this, n plus 1 times n plus 3. And then we could decompose it into two fractions. So we're going to have a over n plus 1 plus b over n plus 2. So now I'm going to multiply both sides. This is supposed to be n plus 3. My mistake. Let's multiply both sides by n plus 1 times n plus 3. So these will cancel. And I'm just going to get a 2 on the left side. And then if we multiply these two things together, the n plus 1 factor will cancel, leaving behind a times n plus 3. And then these will cancel, and so we're going to be left with b times n plus 1. So now, we need to solve for a and b. So I'm going to begin by plugging in negative 3. So this is going to be 2, which is equal to a times negative 3 plus 3 plus b times negative 3 plus 1. So negative 3 plus 3 is 0. That disappears. And negative 3 plus 1 is negative 2. So 2 divided by negative 2 is negative 1. So b is equal to negative 1. Now let's calculate a. So I'm going to plug in negative 1. So this is going to be negative 1 plus 3, which is 2. And then negative 1 plus 1 is 0, so that disappears. 2 divided by 2 is 1, so a is equal to 1. So now we can rewrite the series like this. So it was a over n plus 1, so that's going to be 1 over n plus 1, and then plus b over n plus 3, but b is negative 1. So now we have the series in telescoping form. Now, let's make a listing of the terms so we can come up with a general expression for the partial sum formula. So let's plug in 1. So if we plug in 1, we have n plus 1. 1 plus 1 is 2. And then n plus 3. 1 plus 3 is 4. So this is going to be 1/2 minus 1 over 4. So that's the first term. Now let's get the second term. So let's plug in 2 now. 2 plus 1 is 3. And 2 plus 3 is 5. So it looks like we're going to need a few more terms because just by looking at this, that's supposed to be a sub 2. Nothing cancels. So let's get the third term, a sub 3. Now plugging in 3, 3 plus 1 is 4. And then 3 plus 3 is 6. So at least we can cancel 1 over 4. Now let's get the fourth term. So this is going to be 4 plus 1, which is 5. And then 4 plus 3, that's 7. So now we can cancel 1 over 5. At this point, we could see a pattern with the numbers that are coming up. So look at this, 2, 3, 4, 5. The next one is going to be 6, and then 7. And looking at this, 4, 5, 6, 7. So it stands to reason that the next one is going to be 1 over 8, and then 1 over 9. So what else can we cancel? So we can cancel negative 1 over 7 and positive 1 over 7. We can also cancel negative 1 over 6 and positive 1 over 6. Now if we continue, get the next one, this is going to be 1 over 8 minus 1 over 10. So we can also cancel negative 1 over 8 and positive 1 over 8. So it seems as if we can cancel everything except the first two numbers or first two fractions. Everything else will cancel, but if this trend continues, we're not going to get a 1 over 2 or 1 over 3. I mean, we cancel 1 over 4 and then everything after that, but 1/2 and 1/3 will not be canceled. And it makes sense because looking at the difference between n plus 1 and n plus 3, they differ by 2. In the other example, they differ by 1. Now let's get rid of this. And this as well. Now what I'm going to do is get the a sub n minus 5 term. So you can see what's going on towards the end of the sequence of partial sums. So if we plug in n minus 5 into this expression, n minus 5 plus 1, that's going to be n minus 4. And then n minus 5 plus 3, that's going to be n minus 2. Now let's get the a sub n minus 4 term. So if you go from negative 5 to negative 4, you're pretty much increasing by 1. So I'm going to increase this number by 1, and that's going to be n minus 3, and then just increase this number by 1. And so it's just going to be n minus 1. And then follow the trend. So this is negative 4, negative 3, and then it's going to be negative 2, negative 1, and then n plus 0, or just n, and then the last one is going to be what we see here. So 1 over n plus 1. Here we have -2, -1, and then it's going to be 0, and then it's going to be +1, and then +2, and then +3. I'm going to rewrite this because I'm running out of space. So the last term is going to be 1 over n plus 1 minus 1 over n plus 3. Now, notice what can be canceled. So we can cancel, let's see, 1 over n plus 1 and -1 over n plus 1. What else can we cancel? So we can cancel 1 over n minus 1 and -1 over n minus 1. Also, we can cancel 1 over n, and we can cancel 1 over n minus 2. So everything to the left of these two terms, the last two terms, can be canceled. So if we were to find, let's say, the a sub n minus 6 and the a sub n minus 7 terms, we could cancel these things. It's going to cancel with something in the middle of the sequence. The only things that will not be canceled in this example is the first two fractions here and the last two fractions, not including this one. So 2 fractions in the first two terms and 2 fractions in the last two terms will not be canceled. So the general formula for S sub n is going to be 1/2 plus 1/3 minus 1 over n plus 2 minus 1 over n plus 3. Now let's take the limit as n approaches infinity of S of n. So the constants will not be affected by n, so it's just going to be 1/2 plus 1 over 3. And as n approaches infinity, 1 over n plus 2 will become 0, and 1 over n plus 3 will be 0 as well. So it's just going to be 1/2 plus 1/3. So let's get common denominators. And so this is going to be 3 over 6 plus 2 over 6. So the total sum is 5 over 6. And since we have a finite sum, we could say that the original series converges. And so that's it. Hopefully this gave you a good understanding of how to find the sum of a telescoping series and how to tell if it's convergent or not.